Here's another related race problem. This is probably the hardest one that I've had to do. So pay attention. It says a small funnel in the shape of a cone is being emptied of fluid at a rate of 12 cubic millimeters per second, which means dV dt equals negative 12 millimeters cubed per second. The height of the funnel is 20 milliliters, so big H equals 20, and the radius is 4. How fast is the fluid level dropping when the level stands 5 millimeters above the vertex of the cone? So what we need to find, like the little h equal 5, so that's what we're going to be using this equation. So what we know is the volume of a cone is 1/3 pi r squared h. Okay, so here we go. We need to find the derivative of this. So it goes dV dt equals 1/3 pi times 2r dr dt times h plus r squared dh dt. Now, if you don't understand what I just did there, is I did the product rule of this. So in order to find the derivative of this equation, we have to separate these terms and then multiply. So the product rule is the derivative of the first times the second, and then first times the derivative of the second. So in this case, it would be 2r dr dt times just normal h, then plus normal r squared times the derivative of h, which would be dh dt. Okay, so now I would plug in what I know for dv dt. So I'd say dv dt equals negative 12, and then copy everything else exactly how it is. 2r dr dt h plus r squared dh dt. Okay. So in a cone, we know that the radius is proportional to the height, which means, I'll do it over here, r over h equals 4 over 20. So we cross multiply. 20r equals 4h. And we want to find what r equals in this. So we divide each side by 20. And r equals h over 5. The derivative is what we need because we don't know what dr dt is right now. So dr dt equals 1/5 dh dt. Okay, that will help us later on. Okay, so what I would do now is I'd sub in what I just found into this equation. So it would look something like this. Negative 12 equals 1/3 pi 2 times h over 5, because that is r, times 1/5 dh dt, because that is dr dt, times h plus h over 5 squared dh dt. Now what I would do is I would multiply each side by 3 to get rid of that 1/3, which would equal negative 36 equals pi 2 times h over 5 times 1/5 dH dt times h plus h over 5 squared dH dt. I know this is a long thing, but it's easier to understand if I go step by step. So what I would do now is I'll multiply the terms inside the parentheses. So that would look something like this. 2h squared over 25 dH dt plus h squared over 25 dH dt. Times by negative 36 equals. Okay, so I just multiplied the inside terms. Take a moment and digest all that, because it is kind of tricky. Now what we can do is we can simply just add the terms, because they're similar. So we would get 3h squared dH dt, over 25, is equal to negative 36. That would go to 3 pi h squared over 25 dH dt, which equals negative 36. And because we want dH dt by itself, what I would do is I would multiply each side by the reciprocal of this. So doing that would look something like this, times 25 over 3 pi h squared. And this would obviously cancel out, because that would be 1. So dH over dt would equal negative 900 over 3 pi h squared. Getting very tight on space. But dH dt would equal negative 300 over pi h squared. All I have to do now is sub in the h from up here into the h down here, which would get us 25, because h squared is equal to 5 squared, which is 25. I'm going to come over here for a second. Okay. Which would mean dH over dt equals 300 divided by 25, which is 12. Sorry, negative 300 divided by 25, which is negative 12. The pi just stays there because we leave it in terms of pi. And that would be your answer. dH dt equals negative 12 over pi, because it's asking how fast is the fluid level dropping, and dropping would be negative.